Okay, hello again. So welcome to question 25. In this question, the question says water is being pumped into a spherical tank. So in here, the shape that we have, this is a spherical tank. Okay, so of radius, so this is the radius of the tank. So R of the tank, which is equal to 60 feet. Okay, at the constant rate of 10 feet cubed per second. So this is dv over dt since they said cubed. So dv over dt, and I will put it positive 10 feet cubed per second because they are saying the water is being pumped into the spherical tank. Okay, so this is positive. So in here they are asking us to find the rate at which the radius of the top level of water in the tank change. So in here we need to find the changing in r of water, the radius of the water, because inside the tank, in here we have a spherical tank. So logically, the water inside the tank, it will take the shape of the sphere. Okay, so in here we have a radius for the water. Okay, that's it. So let's imagine that if we have a water, increasing the water inside this tank. So in here we have a radius for this water, and this radius is increasing over the time. So in here at this point, this is the radius of the water. At this point, this is the radius of the water. At this level, this is the radius of the water. Okay, so let's say if we have this okay, let's go back to this. So this is the radius of the tank. Okay, then this is the radius of the water at specific minute. Okay, so in here, this is the radius of the tank, this is the radius of the water. Okay, so in here, this is also the height of the water at specific time. So this is the height of the water. Now, okay, so this is R of tank, this is R of the water, this is the height of the water inside the tank. So in here, what do we need to find? Find the rate at which the radius of the top level of water, which is R of water. So we need to find the rate for the radius of the water, dr of water over dt. Okay, in the tank change when the tank is half full. Now let's imagine that when the tank is half full, so the water, it will be over here. The level of the water, it will be over here, exactly over here, at the middle of the sphere, because it's half full. Okay, now once the water at this level, okay, you can see that the R of the water, it will be exactly equal to R of the tank. So in here, find dr of water over dt when R of the water is equal to R of the tank, which is equal to 60. This is a constant. Okay. Also, what about the H of the water? H is increasing. Okay, so in here, for example, at this level, this is H. At this level, so at this level, this is H. 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 Okay, so once I'm in this level, at this point exactly, H, or the height of the water, it will be exactly also equal to the radius of the tank. So H, it will be also equal to 60 feet. Okay, now we need to find dr of water over dt. So what type of the relation that will connect, or how can I find dr over dt? We need the relation for finding this. So in here, we can see that we have a right triangle. Now, in here, this is an easy method for finding dr over dt by using the Pythagorean theorem, for example. So in here, this is the radius of t, or the radius of the tank. This is the radius of the water at specific time. What about this side? For this side, or the distance between this point and this point, okay, the distance between this point and this point is equal to the radius of tank as well, right? Now in here, the distance between this point and this point at a specific time is equal to the radius of the tank minus h at that time. So the distance between this point and this point is the radius of the tank, the whole radius, minus h, which is the height of the water at that time. So in here, we can say that over here, r of the tank square is equal to, which is the hypotenuse. This is equal to r of water square, okay, plus r of the tank minus h square. This is the relation that I want to find, or I want to use to find dr of water over dt. Now, to find that, I will move this part to this side. So in here, r square w is equal to t square minus rt minus h all square. Okay, now let's see if we have constants over here. Now r of the tank is constant. All the time it will stay in the same level or the same value, which is 60. So let's substitute that. So in here, this is r square of water. This is equal to 60 square minus 60 minus h square. Now for h and r of water, in here for these two values, they are changing over the time. So in here, in this point, for example, r of water is less than r of water at this point, is less than r of water at this point, is less than r of water at this point. Also the h, it keeps changing. So h in here, it's not like h over here, it's not like h over here, it's not like h over here. So h and r, they keep changing over the time. So in here we have a rate for r and we have a rate for h. Okay, good. So now we can start finding the derivative. So finding the derivative, this is 2r of water multiplied by dr of water divided by dt. Okay, this is equal to the derivative of this is equal to 0. This is constant. Then in here, the derivative for that using the chain rule, take the 2. So minus 2 multiplied by 60 minus h. Okay, multiplied by the derivative of what inside, which is minus h prime or dh over dt. Okay, so now after simplifying, this is 2r of water dr of water over dt. This is equal to minus multiplied by minus. This is in here positive. Then, okay, so this is 2 divided by 60 minus h dh over dt. Okay, what about this? Now in here, do we have r of water at that time? Yes, we have 60 because they are saying find dr over dt when the tank is half full. So we have the value of rw, which is equal, or r water, which is equal to 60. Do we have the value of dr over dt? We need to find that. Do we have the value of h? Yes, we have the value of h. Do we have the value of dh over dt? No, we don't have the value for that. We don't have, they haven't mentioned anything about dh over dt. Okay, so we need to find dh over dt. So how to do that? Okay, so what relation can I use for finding dh over dt? Now for finding dh over dt, we can use the rule which is called the volume of spherical cap. So the volume of the spherical cap, this is equal to V is equal to by R of the tank H square minus 1 over 3 by H cubed. Okay, that's it. This is the rule how to calculate the volume, okay, of the water inside a spherical tank. Okay, so this is the volume of the spherical cap. Now let's start substituting the constants. So V is equal, or the volume is equal to pi multiplied by the constant, which is out of the tank, which is equal to 60 h squared. And here we have a rate for h, so I'm not going to substitute it. So pi over 3 h cubed. Now I'll start finding the derivative. dv over dt is equal to, in here we have 2 multiplied by 60, which is 120 by h dh over dt, minus 3 multiplied by pi over 3, this is pi h squared dh over dt. Now all we have to do is just substituting. So in here we have 10, in here we have 120 multiplied by 60. Let's calculate that. So on the calculator, 120 multiplied by 60, which is the value of h. So this is 7,200 by dh over dt. Okay, dt. We can take the dh over dt as a greatest common factor over here. Whatever. So in here, multiplied by or minus by multiplied by 60 square, which is equal to 3,600 by dh over dt. Okay, now we can take dh over t as a greatest common factor and divide by these two values. So this is 10 equal to 7,200 by, okay, minus 3,600 by multiplied by dh over dt. Now we can subtract these, which is 7,200 minus 3,600, okay, which is equal to 3,600 by multiplied by dh over dt. Okay, this is equal to 10. Now in here we can say that dh over dt is equal to 10 divided by 3,600 by, which is equal to 1 over 360 pi. Okay, so in here it's fit per second. So we can go directly to substitute this value. So in here, this is the substitution. This is my substitution. In here, I have to substitute 2 multiplied by 60, which is R of water, dr of water divided by dt. This is equal to 2. I'm substituting this relation, by the way. So 2 multiplied by 60 minus 60 multiplied by dh over dt, which is 1 over 360. Okay, by. Now this is equal to 0. 0. So dividing by 2 multiplied by 60, which is equal to 0. So the dr of water over dt is equal to 0 foot per second. Okay, that's it. This is the value. So this is part A.